Hello dear children, this is Preeti Chhabra and I welcome you all to Learning Never Stops. We have completed the chapter Study of Gas Laws. Today we are going to do the numericals of the chapter. Okay, so let's start. Now let us look at the question. The question says, at a constant temperature, volume of a gas was found to be 400 centimeter cube. So let us write down what is given. Volume of the gas is 400 centimeter cube. This is given. At a pressure of, so pressure is also given. What is the pressure? When volume is 400 centimeter cube, the pressure is 760 mmHg. So it is 760 mmHg. This is the pressure which is given. If the pressure of the gas is increased by 25%, find the new volume. That means P2 is, what is P2? It is 25% of P1. What is P1? 760. Okay. So what is 25% of 760? This is 760 and this is 25% of 760. On calculating this, you get 190. Now P2 is, the gas is increased by 25%. That means 760 plus the 25% of 760. So it is 190 plus 760 and you get 950. So P2 is 950 mmHg. Okay. What you have to find? You have to find V2. That is the new volume. Fine. So this is clearly the Boyle's law, where pressure and volume are given and the temperature is constant. So relationship is between pressure and volume. So this is the Boyle's law. What is the formula of Boyle's law? It is P1 V1 is equal to P2 V2. You simply have to put down the values and find out the value of V2. What is P1? It's 760. What is V1? It's 400. Clear? This is equal to, what is P2? 950 and V2. You have to solve V2. So V2 is equal to 760 into 400 divided by 950. On solving this, you get V2 to be equal to 320 centimeter cube. Don't forget to mention the units. Here this is mmHg, here also this is pressure mmHg. वो कट जाएंगे and इसका unit मिलेगा centimeter cube in the answer. Now let us look at the second question. The second question is, a vessel of capacity 600 centimeter cube. That means capacity of 600 centimeter cube means the volume. A vessel of capacity 600 centimeter cube contains hydrogen gas at a pressure of 304 centimeter Hg. So again, volume is given 600 centimeter cube and pressure at 600 centimeter, when the volume is 600 centimeter cube, pressure is 304 centimeter Hg. Okay, this is given. Then it says, what will be the pressure? Here it is asking to find out the pressure. Okay, what will be the pressure? That means what you have to find out? You have to find out the pressure of the hydrogen gas when the vessel is connected to another vessel of 300 centimeter capacity. एक वेसल था 600 सेंटीमीटर कैपेसिटी का, दैट इज V1. उस टाइम पे प्रेशर है 304 सेंटीमीटर Hg. नाउ इट सेज कि प्रेशर क्या होगा जब दिस वेसल विच हैज़ द कैपेसिटी 600 सेंटीमीटर क्यूब इज कनेक्टेड, एक और वेसल के साथ उसको कनेक्ट किया, जो जिस वेसल के साथ उसको कनेक्ट किया है अब उस वेसल की कैपेसिटी है 300 सेंटीमीटर क्यूब. तो V2 कैपेसिटी कितनी होगी? इसको इसके साथ कनेक्ट कर दिए, दैट मीन्स 600 centimeter cube plus 300 centimeter cube, this would be V2. So this is 900, 600 plus 300, 900 centimeter cube. This is V2. Again, this is clearly a sum from Boyle's law. So again, the formula goes P1 V1 is equal to P2 V2, whereby P1 is 304, V1 is 600, and P2 you have to find out. And what is V2? 900 centimeter cube. Fine. So simply solve it. P2 is equal to 304 into 600 divided by, this will come here, 900. So this is 3, 2. This is 608 by 3. On solving this, you get 202.67. You have to find out pressure. So unit is centimeter Hg. Now the next question is, prove that the volume of a gas at 273 degrees centigrade, 273 degrees centigrade means it's the temperature. The volume at this particular temperature is twice its volume at 273 Kelvin at constant pressure. When the pressure is constant and the relationship is given between volume and temperature, that means that this is Charles's law. Okay. So V1 we don't know. T1 is 273 degrees centigrade. Okay. What will be the volume V2? We don't know, but you have to prove that this V1 is 2 times V2. This volume is twice its volume at 273. जो भी volume 273 यानी T2 which is 273 Kelvin, ये V2 जो भी आने वाला है T2 पे, V1 इस volume का 2 times होना चाहिए. This you have to prove. Now here this is in Kelvin and this is in centigrade. First of all you have to convert the unit. Unit same होना चाहिए for calculation. So you have to convert 273 centigrade, degree centigrade to Kelvin. How can you convert it? By simply adding 273 to it. जो भी temperature degree centigrade में है, you just add 273 to it and you get the answer in Kelvin. So this is 546 Kelvin. Okay. Now you got T1, you have T2. What does the formula say? Charles's law, it's V1 by T1 is equal to V2 by T2 at constant pressure. V1 by what is T1? It is 546 Kelvin. So you write 546 Kelvin here. This should be equal to V2 by at what temperature? T2 is 273 Kelvin. 273 Kelvin. Okay. Now 273 into V1 is equal to 546 into V2. Okay. So V1 is equal to, this would go here, 546 by 273 into V2. This is 2. Okay. So what you got? V1 is equal to 2 times V2. So hence proved. Hence proved. Okay. Now let's see the next question. A gas occupies 3 liter. That means this is the volume. First of all, you must write the information which is given. So V1 is 3 liter. At 0 degree centigrade, that means T1. At T1, which is 0 degree centigrade, V1 is given to be 3 liters. What volume will it occupy? That means you have to find out V2. what volume will it occupy? That means you have to find out V2 at what is the temperature given? T2 is minus 20 degrees centigrade. Pressure remaining constant. So clearly again this is a question from Charles's law. Now here units दोनों same है, degree centigrade, but you cannot continue with this unit because Charles's law is T1 by T1 is equal to V2 by T2. Here T is the temperature in the Kelvin scale. So you have to convert these units from degree centigrade into Kelvin scale. So T1 would be 0 plus 273 coming to be 273 Kelvin, and minus 20 degrees centigrade plus 273 is 253 Kelvin. Okay, so putting the values इस वाले formula में V1 is 3 liters by T1 is 273 Kelvin. Okay, this is equal to V2 by T2. You have to find out V2, and what is T2? It is 253 Kelvin. Okay, this is very important, children. You have to convert degree centigrade into Kelvin. So here on solving this you get V2 is equal to 3 into 253 divided by 273, and on solving this you get 2.78. Now let's see this. What temperature would be necessary? What temperature would be necessary? That means they are asking for the temperature. What temperature would be necessary to double the volume of a gas? जो भी वॉल्यूम किसी गैस का रहा होगा, अगर उसे मुझे डबल करना हुआ, अगर मैं वॉल्यूम को डबल करूं तो क्या चेंज आएगा टेम्परेचर में? इनिशियली एट एसटीपी, जो स्टार्टिंग में इनिशियली स्टार्टिंग में अगर एसटीपी पे हुआ, एसटीपी मीन्स स्टैंडर्ड टेम्परेचर प्रेशर, वी हैव ऑलरेडी डन स्टैंडर्ड टेम्परेचर प्रेशर इन द चैप्टर. एक स्टैंडर्ड टेम्परेचर होता है, एक स्टैंडर्ड प्रेशर होता है गैस का. उस स्टैंडर्ड टेम्परेचर पे इनिशियली अगर गैस है तो एक पर्टिकुलर वॉल्यूम ऑक्यूपाई किया होगा उसने. अगर उस वॉल्यूम को मुझे डबल करना हुआ तो अब स्टैंडर्ड टेम्परेचर से क्या चेंज आएगा टेम्परेचर में? दे आर आस्किंग, एंड इट्स गिवन कि द प्रेशर इज़ रिड्यूस्ड, इट्स डिक्रीज्ड टू 50%. अगर जो भी स्टैंडर्ड प्रेशर को 50% डिक्रीज कर दिया जाए, सो हियर वी कैन सी द रिलेशनशिप बिटवीन all the three variables, that is volume, pressure and temperature. Okay, so you have to solve this with the gas equation, which is P1 V1 by T1 is equal to P2 V2 by T2, right? So here the question is you have to find out T2. What is T1? It is standard temperature. What is the standard temperature? It's 273 Kelvin or 0 degree centigrade, but we will take Kelvin. Then the pressure is decreased to 50%. Initially it was at standard pressure. What is the standard pressure? It's 760 mmHg. So it is reduced, decreased to 50%. So 760. Okay, so this you get 380 mmHg. So this is your P2. Clear? So putting the values you get P1 initial, that is 760, sorry, this is 760. V1, we'll keep it as V1. T1, its standard temperature, it's 273 Kelvin. This is equal to P2, which is reduced to 380. So P2 is 380. We will now take V2 to be 2V2. Why? Because what temperature would be necessary? That means T2 you have to find out to double the volume. That means here you have to double the volume. वॉल्यूम अगर V1 था उसे मुझे अगर डबल करना हुआ तो मुझे T2 फाइंड आउट करना है. क्लियर? दिस V1 हैज़ टू बी डबल्ड. ये डबल वॉल्यूम पे T2. सो दिस 2V1 इज V2. What is the value of V2? Twice V1. Clear? If you double the volume of the gas, so we have doubled the volume of the gas. At this doubled volume, we have to find out T2. So solving this, we get T2 into 760 V1 is equal to 380 into twice V1 into, this will go that side, into 273. Clear? I'll rub this. You have to find out T2. So T2 is equal to 380 into twice V1, okay, into 273 divided by 760 into V1. So this V1 gets cancelled, and here you get T2 to be equal to 273 Kelvin. Okay. So did you find any change in the temperature? No change, because when we doubled the volume, we decreased the pressure to half. So temperature did not change at all. Now let us look at this question. Which will have greater volume? That means you have to find out the volume when the following gases, these two gases, nitrogen and oxygen, are compared at STP. So one by one you have to solve this. First you have to solve this part. 1.2 liter of nitrogen, that means volume, V1 here is given 1.2 liter, and temperature is given to be 25 degrees centigrade, and the pressure here is 748 mmHg. Let us first solve this one. You have to compare these two gases, which will have greater volume at STP. तो इन दोनों का वॉल्यूम एट स्टैंडर्ड टेम्परेचर प्रेशर पे जो भी दोनों का वॉल्यूम होगा, इन दोनों गैसेस में से किसका वॉल्यूम वुड बी ग्रेटर, दिस इज बीइंग आस्क्ड. ओके, अभी एक पर्टिकुलर टेम्परेचर दिया है, एक पर्टिकुलर प्रेशर दिया है, बट इसको अगर आप स्टैंडर्ड टेम्परेचर प्रेशर पे इसका वॉल्यूम कैलकुलेट करो एंड इसका भी स्टैंडर्ड टेम्परेचर प्रेशर पे वॉल्यूम देखो, देन यू हैव टू कंपेयर कि किसका वॉल्यूम वुड बी ग्रेटर. So very simple, let's start with this. Since all the three variables are given, relationship between all the three, so we'll solve it with the gas law. So for this, P1 V1 by T1 is equal to P2 V2 by T2. Simply you have to just put the values. Now P1 here is 748 mmHg. So we'll write 748 mmHg here. V1 at this pressure is 1.2 liters. So we write 1.2 liter divided by T1 here is 25 degrees centigrade, which has to be converted in the Kelvin scale. So it is 25 plus 273 degrees centigrade, and you get 298 Kelvin. Clear? Now this has to be compared with what? At standard pressure temperature, volume at standard pressure temperature. What is standard pressure? It's 760 mmHg. At this standard pressure and the standard temperature, which is 273 Kelvin, you have to find out the volume. So on solving this, you get 760 into V2 into 298 is equal to this. And so directly we write V2 is equal to 748 into 1.2 into 273, okay, divided by 760 into 298. Clear? So V2 is 1.08. You calculate this and you will get the value 1.08 liter. This is V2. Okay, V2, that means for nitrogen gas, volume at standard temperature pressure. Now this is very simple. This is the volume of oxygen already given at standard temperature pressure. So for oxygen, what is the volume? For nitrogen gas, the volume at standard temperature pressure is 1.08 liter, एंड फॉर ऑक्सीजन ये तो ऑलरेडी STP में ही वैल्यू दी हुई है. सो वॉल्यूम फॉर O2 gas at standard temperature pressure is already given, which is 1.25 liter. So you have to compare this volume with this volume and say which is the greater volume. So what is the volume here for N2 at STP? It's 1.08, yeah, 1.08, and for O2 it is already given in the STP, so it is 1.25. Which one is greater? This one is greater. So the oxygen gas, that is 1.25 liter oxygen at STP, this gas has greater volume at STP. See children, all the numericals are very simple. You just have to see कि information क्या दी हुई है, and very simple. 2-3 ही हैं equations, Boyle's law, Charles's law, gas equation. The numericals of this chapter are very very simple yet very very important. So I hope the concept is clear, and I think अब आप सारे numericals इस chapter से easily solve कर सकते हो. If you have any queries, any doubts related to the topic, please feel free to ask me in the comment section. I would love to answer your questions related to that topic. Okay, hope to see you in my next video, for which you need to subscribe to the channel. Till then, take care. Bye bye.